up the Christmas presents? Yes. Don't open the presents! Can we open the presents?
No, but you can count them.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did you count that one? Yes. 15 presents. I wonder how much are in the whole neighborhood. I think 5,000. I can think of bigger numbers than that. What about 1,000,000 to trillion? That's not a real number. Yes, it is. No, it isn't. Do you know?
I don't know how many presents there are in the neighborhood, but we can try to calculate it using a Fermi estimation.
What's a Fermi approximation?
Well, a Fermi approximation is how scientists calculate really big numbers when they cannot count every single thing.
Oh, like drag in the numbers of planets with aliens on them?
Yes. So, if we want to figure out how many presents there are in the neighborhood, we're going to need to know a couple things about the neighborhood. What are some things we might need to know? Peyton?
How much houses there are?
Good. What else might we want to know? Yes, Parker?
How much people there are?
Yes, we want to know how many people there are in the neighborhood. That's good. Anything else we might need to know? Peyton?
How much pets they have? Because we give presents to our cat like Buddy.
So anything else we might need to know?
Just when we give Buddy. How much people celebrate Christmas?
Yes, we're going to need to know the percentage of people who celebrate Christmas.
Because some people don't celebrate Christmas. They celebrate other holidays. Like Hanukkah.
Now,
We can
let's
go outside.
Yes, we're going to go outside and see if we can figure out how many houses there are. Ready to figure out how many houses there are in the neighborhood?
Yes.
Okay, so we're going to count how many houses there are in one block, and then we're going to count how many blocks there are.
Each block has the same amount of houses. No, because some of these blocks could.
Right. It's going to take too long for us to count every single house, so we're just going to assume that each block has about the same number of houses. We're just going to need to do our best to guess, okay? So, let's go and start counting houses.
1, 2, 3, 4, 5, 6, 7, 8, 9.
How many houses did we get on this side of the block? Peyton?
10.
10. Okay, so are all sides of the block the same?
No.
No? Are some sides shorter than others? So we're going to need to count a shorter side, okay? Let's see how many houses are on this side of the street.
1, 2.
So, how many houses were there on this side? 2 houses?
2.
We counted that the long side of the block had how many houses?
10.
And the short side had?
2.
2. The long side of the block has 10 houses, and the short side has 2 houses. How many houses in one block?
24.
Okay, so 24 houses in one block. Now, we need to figure out how many blocks are in the neighborhood. Now we need how many blocks long the neighborhood is, and how many blocks wide.
5.
5 blocks long, and how many blocks wide?
10.
10. So if it's 5 blocks long and 10 blocks wide, how many blocks are there?
15.
Not 15. That'd be 10 plus 5. We need to do 10 multiplied by 5.
So 10 groups of 5?
Yes. No.
50.
50. We have 5 tens, that's 50. So we know how many houses there are in the block and how many blocks there are in a neighborhood. But remember, does everyone celebrate Christmas?
No.
No. So how could we guess how many people celebrate Christmas?
By looking at the Christmas decorations, if they have it.
How many houses on the side of the block with 10 houses had Christmas decorations?
6.
6? Okay, so 6 out of 10 houses celebrate Christmas. So if we know how many houses celebrate Christmas, we also need to know What else about each house if we want to know how many presents are in the house?
How much people?
How many people?
How much pets?
And how many pets? How many people do you think live in one house? Yes.
6.
6. What do you think, Peyton?
6.
Okay, so about 6 people per house. Does that include the number of pets?
Actually, I think 5. Yes. Yes, 5. Because we have 5 people in our family. Not everyone. Yeah, 5 people in this house.
What would be the smallest home, you think?
What of the 2 houses up there? They only have like 2 or 1 person.
What do you think is the biggest?
Oh, yeah, no, it's the one next door over there.
How many people are in the whole house?
7.
7. Do
Counting
they have
pets.
Counting pets?
Because
Okay.
they have 2 pets.
So we have some houses that have 1. Your house has 5. Your friend's house has 7.
One of my other friend's house has 4.
And another friend has 4.
Wait, and one of my other friends has 2.
Do you think there's more houses with lots of people or small numbers of people?
Lots. Small.
Small.
Yeah, small.
No.
Because there's 1,
Mhm.
2, 3.
So what number do you think we should use?
4. 3. 4.
So 3 and 4. How about we do the average and say 3.5?
Like that.
That means that if we have 2 houses, one of them will have 3 and the other one will have 4. And they average to 3.5.
Weird.
So if we know the number of people in the house, how could we guess how many presents there are?
How old they are, that's how much presents they should get. Double the number of how much people. Oh my gosh. Mom's 39. Why,
Actually-
79. No, she should not have 79. 79. No, she should.
How about we count how many presents there are under your tree? Remember how many presents there are here?
15.
15. Okay, and how many people
fair.
live in your house?
5.
If there's 15 presents and there's 5 people, how many presents does each person get?
3.
Yes, so each person gets about 3 presents. So now, we just need to plug all of these numbers into a calculator, and we can guess how many presents there are.
Oh, I'll go get my calculator now.
Yes, go get a calculator. Can I see the calculator?
First, I have to turn it on.
We have 24 houses in one block, 50 blocks in one neighborhood. We have about 6 houses out of 10 celebrate Christmas, 3.5 people per house, and we have 3 presents per person equals 7,560 presents in our neighborhood.
Oh my gosh.
So this is an example of how scientists, such as Fermi, approximate very large numbers by first taking a small sample, like we did by looking at our one block in the neighborhood, arguing about the typical value of some quantities, like we did with our discussion of how many people are at each house on average, then extrapolating to the whole, we went from the block to a neighborhood to get a much larger number. There's many examples of these type of Fermi estimations or Fermi approximations in science. A famous one is the Dirac equation that calculates how many planets there should be in our galaxy with alien life forms. Wow, so that's over 7,000 presents in your neighborhood.
Before we have to say the presence of the city, the state. We said do the whole country, the continent, the whole world, universe.